Today we're talking about congruence, and we've talked a lot about congruent angles and congruent segments, but we've never really talked about congruent shapes, and that's kind of the focus of most of the rest of this chapter. So let's talk about what it takes for shapes to be congruent. And if I broke a tile in my bathroom, if I went to buy a new tile, obviously I want to replace it with a congruent tile. So what would I want to measure to make sure that it's going to fit well? I would want to measure all of the sides to make sure that all of the sides are congruent. On this particular tile, all of those sides match, and we call sides that go together, we call those corresponding sides. And then I'd check these shorter sides too. But I wouldn't want to just measure the sides to make those fit. I would want to make sure that the angles are going to be right too. So I'd want to go in and measure all of the angles to make sure that each corresponding angle will be a good fit. It turns out that this particular tile is an equiangular tile, so that makes my job a little bit easier. But congruent figures, the definition is that all corresponding parts, the angles and the sides, have to be congruent. Everything has to match up. We're mostly going to talk about triangles in this section. First of all, I see everything I need marked on these two triangles. Let's start with all the congruent sides that are marked. Let's start with those single ticks. Do you see how JK has a single tick? So JK is marked congruent to single tick ST. Double ticks, KL is marked congruent to double tick SR. Triple tick, JL is marked congruent to RT with a triple tick. And then our angles, single swoop K is congruent to angle S with a single swoop. Double swoops, angle L congruent to angle R. And then triple swoops, angle J congruent to angle T. Now the big thing I want you to pay attention to is when they ask you to write a congruence statement. First of all, what does that mean? It means that they want you to write that triangle something 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 is congruent to triangle something something something. But the order of the letters is actually very important. So you can pick anything for the first triangle. Should we just call this first triangle JKL? Nice and alphabetical. But that doesn't guarantee that I'm going to go nice and alphabetical in the second triangle. Did you notice that I started with the letter J in the first triangle? That was my triple swoop vertex, right? So that means that for my second triangle, I need to start with my triple swoop vertex. So I have to start with the letter T. Then I moved to vertex K, which was my single swoop. So in my second one, I need to move then to vertex S. And then there's just one left. The double swoop L matches up with the double swoop R, so since I ended with L, I'll end with R. So the congruence statement says that those triangles are congruent and the order of the letters really matters. And if in a problem they give us a congruence statement, we can totally use that to help us solve the problem. For example, I know that the side AB has to match with the side FG. So on this picture, side AB has to match with side FG. That makes it really easy, especially if they had like twisted this one around, it was upside down or even flipped around. That makes it really hard to figure out which side matches with which side. So if I were solving this algebra problem, that would make this really easy. We would say that the 9 has to match with the 3x minus 6. Add 6 to both sides. Divide both sides by 3, and I have x equals 5. Plug that back in, see what happens. 3 times 5 minus 6 would be 9, and that's a good sign. The next one I'm trying to solve is angle K right here. And if I wasn't sure which angle K matched up with, in this picture it's probably pretty obvious, but I could always go to that congruence statement. You see how K comes last Well, D comes last in the other shape, so I would know that angle K has to match up with angle D. Good news, I already know that x equals 5, so that'll make this problem a little bit easier. And if we go plug that back in, we'd have 4 times 5 is 20, 2 times 12 is 24, and 20 plus 24 would be 44. Great sign, those are congruent. So these figures are congruent as long as all of the corresponding sides are congruent and all of the corresponding angles are congruent. Now this is the last chapter that we'll get to do some hardcore proofs. Sorry if that disappoints you. We are going to try to prove that these two triangles are congruent. We have a couple of givens that are already marked on the picture. We have GH is congruent to ST, and GT and HS bisect each other at O. If we want to prove the triangles are congruent, that means that we need to prove that 3 corresponding sides are congruent and 3 corresponding angles are congruent. I like to make a little note off to the side. Did you notice we were already given a set of corresponding sides that are congruent? So I like to mark that with a little S to show that I've already got one set of sides. And I've got this word bisect. Do you remember what happens when we see a vocab word in the given? We're going to use the definition of that word as a reason. So what does it mean to bisect? To bisect a segment. Definition of a segment bisector. Well, if GT and HS bisect each other at O, that means they cut each other in half. So that gives us some nice congruence, right? If they cut each other in half, we can say that this piece is congruent to this piece. That one gets cut in half. And this piece is congruent to this piece. I'll use a triple tick. And really, we use the same reason for both of those, right? And so we already have 3 sets of corresponding sides marked congruent. I'd say we're halfway there. Now it's time to try to get 3 sets of corresponding angles congruent. Can we do it? The good news is we have some parallel lines. And don't parallel lines usually give us some congruent angles? Yeah. So it might help to think, okay, if these lines are parallel, what could we use for a transversal? Maybe we could use this for a transversal. Can you see any angles then that would be congruent? Could we say that angle H up here and angle S down here, wouldn't those be alternate interiors? Do you remember me telling you about if it forms the letter Z, those are alternate interiors? So angles H and S are alternate interiors. The only reason we can say those are congruent is because we had those parallel lines. So parallel lines led us to the alternate interior angles being congruent. That's one pair of angles. Can we find another pair of angles? Well, I say we can use those parallel lines again. What if we just used this line as the transversal this time? Do you feel like we could use this angle and this angle as alternate interiors? I know I was talking about Z's making alternate interiors, but this is sort of a backward Z. Can you see it? So even backward Z's, we can consider those alternate interiors. So I could say angle G and angle T are alternate interior. Again, that only works because I was given those parallel lines. Now we have another set of corresponding angles congruent. Almost there. We need 3 sets of sides and 3 sets of angles. How are we going to get that last set of angles, friends? I would need to somehow show that this angle was congruent to this angle. Is that believable for any reason? Is anybody looking at this crisscross right here? Doesn't that look like those angles are formed by an X? What type of angles are those? Do you recognize those as vertical angles? They're always congruent. Excellent. Now I can't just call those both angle O, so I'll have to use 3 letters, I suppose, right? That trace around there. So how about this top one, we call it GOH. And the bottom one we could call TOS. And why are those congruent? Because they're vertical angles. The vertical angles congruence theorem. And that's what we needed to do, you guys. That's all. Now we can say that those triangles are congruent to each other. Again, we can name the top one anything we want. What if we call it GOH? Then we just have to be careful on the bottom one. Which vertex matches with G? The double swoop was the T. And the O on the bottom matches with the O. And the H on the top matches with the S on the bottom. So just make sure you're getting those letters in the corresponding places. And what reason do we use? I would say the definition of congruent triangles. The definition of congruent triangles says that all of the corresponding sides and all of the corresponding angles are congruent. Here's just a little bonus theorem that could help us today. Let's say we were able to prove that angle A was congruent to angle D and angle B was congruent to angle E, but we didn't have a reason to say that C was congruent to F. Well, now we have a reason. This theorem is called the third angles theorem. It says that if you can prove that 2 sets of angles are congruent, then you're guaranteed that that third set of angles will match up. The punchline says the third angles are also congruent. If A is congruent to D and B is congruent to E, then C is congruent to F. And I think it makes sense. If you had a 70-degree and an 80-degree angle on one triangle, if we use the triangle sum theorem, how big does that last angle have to be? These two already add up to 150, so if it has to be 180 total, would that be a 30-degree angle to complete the 180? So would that ever turn out differently for a triangle that also has another 70 and an 80? No, of course not. So if you have 2 angles that are already congruent, of course that third angle will be congruent too. That's what the third angles theorem says.